Lesson 1A.10, Analyzing Polynomials with a Calculator. In this lesson, we're going to utilize the NumWorks calculator. So if you are using any other style of calculator other than NumWorks, you are watching the wrong video. So feel free to keep watching. You don't have this calculator, try something else. All right, so what we need to be able to do is to graph a function, evaluate a function, identify intercepts and extrema using technology. Now, since the only people now watching this video are the NumWorks people, congratulations. This is the easiest calculator to use to establish these skills. The NumWorks is designed specifically with you, a high school student, in mind. And they made it as easy as possible to do all of this. So this should be a pretty short video. Now, I don't have a digital copy software of the NumWorks, but good news is NumWorks, if you go to numworks.com/simulator, here is a full and complete copy of the NumWorks calculator. You can also get a NumWorks calculator on your phone by downloading it from the App Store on iOS and Android, completely free. TI does not offer that sort of thing. You can get bootleg copies, but NumWorks makes it easy. They want to put product in hands. So here is the calculator. So let's go ahead and start. We want to graph the function y equals 3x squared plus 10x minus 8. So let's go ahead and do that. To graph it, we're going to go to the grapher. Calculation, if I hit enter right now, this would be for standard calculation. So like 6 plus 9 equals 15. Great. 7 divided by 5 is 1.4 or 7/5. I can also scroll up and highlight things. So it's 7/5, it's 1.4. If I click this, it'll actually show me different versions of that same fraction. 7/5 is the same thing as 1 and 2/5. It's the same thing as 5 times 1 plus 2. No idea why you would want that, but if I hit the back button, it'll take me back. Hit the home button, it'll take me to the home screen. Simply select the app of what you want to do right now. I want to graph something, so I'm going to go to the grapher. I have add an element as an option, so I'm going to select enter to add an element. If I go over here to templates, it gives me options of some basic types of functions I might want to add. We're going to use a lot of these throughout the year. But right now, again, I just wanted to graph y equals 3x squared plus 10x minus 8. So I'm going to go all the way back up here. Y equals x is essentially what I want to do. It was 10x squared. To get the square, I'm going to hit this button on the right. 10x squared plus, 3x squared plus 10x. All right, let's edit. So let's change that 10 to a 3. I'm going to hit the backspace. 3x squared plus 10x, and then what was it? Minus 8. Minus 8. So 3x squared plus 10x minus 8. Hit execute to lock it in. Now notice it immediately identifies this function as a parabola. So I know it's quadratic. It's going to be a parabola. The calculator knows it. It might as well just tell you, hey, I'm about to graph a parabola. Now, if I don't need to do this right now, but if I were to go over here to these dots and hit enter, I can change some options about it. I can, for example, in details, it'll give me details about the parabola if we were working on conic sections. Notice vertex is at negative 1.666 and negative 16.333. One of the questions I'm going to ask you is, oops, not that. One of the questions I'm going to ask you is to identify extrema. Stop that. This one. Extrema on a parabola would be the vertex. There's the vertex. The vertex is right there at negative 1.666, comma, negative 16.333. I can, without even looking at the grapher, I can see some basic information. I'm going to hit the back key. I'm about to graph it. I can change the color. Derivatives, this is for calculus. Plot restriction, this will come up later. I can show both, showing both the graph and the table the function. I can delete the function. None of that is relevant right now. I'm going to hit the back. And then if I go up, notice I have expressions highlighted. I want to see the graph, so here's the graph. So when I hit graph, it shows me the entire graph. It will auto It will auto adjust my window. If I make sure that auto is selected, notice if I go up and hit enter, I've now turned auto off. So now if I go left and right, I can move around the curve. I can just travel around it. But if I go back up here and select auto, it'll readjust it back so that I can see all the what the calculator thinks is important information. Notice that it's highlighted my x-intercepts and my minimum. If I go left and right, my minimum value is right here. It will automatically snap to that minimum value. And see, there's that vertex, negative 1.66666 repeating, negative, so keep in mind the 7 is just a rounding error. It's just rounding off the last digit to a 7. I personally don't like that, but it does it automatically. There's the coordinate. Now, one of my questions was to identify the extrema. I'm just going to list out the x values. It was 1.666, so negative 1.666. So I have a identify extreme. I have a relative minimum at x equals negative 1.666. If the question asks for the coordinate of the extreme value, then give the full coordinate. Otherwise, the default is just list out the x values. Also notice I'm doing 3 decimal accuracy. Unless you are told otherwise, stop hitting that button. Let me go ahead and just close that. Unless you are told otherwise, you are always doing 3 decimal accuracy on decimal values. All right, 3 digits of decimals, 3 digits past the decimal point is always the standard in AP Calculus and AP Pre-Calculus. If you're told otherwise, follow the directions. 3 decimal accuracy, 3 decimal accuracy, 3 decimal accuracy. All right, let's keep going. We also need to identify intercepts. And the intercepts are the the values that are also highlighted on the graph. So notice if I go up here to the left, it looks like the intercept's at -4, but I just want to confirm. If I highlight it, it'll highlight and say 0. An x-intercept is also called a 0. Notice the y value is 0. The x value is -4. So I have an x-intercept at -4. I have another x-intercept at 0.666 repeating. So I have x-intercepts at -4 and 0.666 repeating. Now keep in mind 0.666 repeating, that's just 2/3. So I'm going to write 2/3. Just like negative 1.666, that's just 5/3. You could just write 5/3. That's perfectly fine. And then we also had a y-intercept somewhere. The y-intercept looks like it's at -8. Just to confirm, highlighting it, y-intercept, x equals 0, y equals -8. So y-intercept is at -8. Of course, the y-intercept is also just the constant term. Given a polynomial, the y-intercept is always the constant term. So I've graphed it. It will automatically highlight maximums and minimums. It will automatically highlight x and y intercepts. You just have to scroll left and right to snap the cursor to the desired value. The only other thing we need to do is evaluate at a function. So if I ask you what's f of 2, for example, I could type in 2 into the function and calculate it, but I have the graph. So at 2, what I want to do is go up here to calculate. All right, so if I just change the x value to 2, it will show me x equals 2 on the x-axis, and then notice the y value is 24. So evaluate f of 2 is 24. So I can do it that way. I can also, so I can change the x value. I can also notice I can change the y value. A second ago when I was looking for zeros, if I change the y value to 0, it will actually spit out at least wherever I left off, wherever my window was most recently, it'll spit out the closest x value to when y value is 0. Notice here on the y value it says 6.661338 e -16. This happens on the TIs as well. That e is scientific notation. So it really says 6.661 times 10 to the -16. So this is 0.0000000000, a bunch of zeros, and then a 6. The calculator is not perfect at finding x-intercepts, so a lot of times it'll just estimate. When you see y equals with an e in it, that's scientific notation. It's probably a really, really, really small number, in which case it's basically 0. So your x-intercept is at 0.666, y equals 0. So right where we expected it to be. If I go up here, just to show you a few more things, find x given y, that's the same thing we just did. If I wanted a y value of 0, it would spit out one of the answers. It's not going to spit out both of the answers. If I hit the minus button, it'll actually zoom out, and I can see more of the graph. Maybe not. If I hit the back button, there we go. If I hit the back button, I can find the other one. If I go up here again to calculate, find x given a y. If I give a y value of 0 and confirm, it'll spit out. Notice my cursor was all the way to the left, so it spit out the x-intercept that was closest to that cursor. Completely unnecessary, but it's just multiple ways to do this in your calculator. Just graph it and look for the x-intercepts and the y-intercepts. It'll find it for you. But just to go back to evaluating, there's one other option. If I go back to the home screen, actually not to the home screen, let's go back to the grapher and go back to expressions. Originally, when I typed in this expression, I typed it as y equals. I'm going to hit execute. Instead of writing y equals, I can literally use function notation on this calculator. I want to type f of x. There's an alpha button on my calculator. If I hit alpha f and then parenthesis x, close parenthesis, I now have this polynomial function labeled using function notation. If I go to my calculation menu, let's go ahead and clear all this out because I don't need it. And I literally type alpha f of 2. It will evaluate f of 2 for me, which is 24, the same answer I got before, using function notation. This calculator understands function notation. Feel free to use it, but if you're going to use it, you got to remember to type functions in using function notation. Once I'm done with a function, I can just go in and delete the expression. Keep in mind when I go to add the element, function notation, I could default to function notation. I could just start with that instead of typing it in after the fact. All right, so now we have seen how to graph something, evaluate something, and identify intercepts. So here's another one. Try this. Pause here, play when you're ready. So let's go ahead and type this in, 2x cubed, 2x cubed, 2x cubed. So I'm going to just use function notation this time. So, and it's supposed to be 2x cubed. I'm going to use this button right here for the exponent. And then minus 13x squared, minus 13x squared, minus 29x, minus 29x, plus 40, plus 40. All right, lock it in. There's my function. Let's go ahead and graph it. All right, notice that the auto is currently turned off. If I hit back, left, down, turn on auto, it's going to adjust my window to everything that I need to see. Notice I've got 3 x-intercepts, I've got a maximum, a minimum, and a y-intercept all highlighted for me. So let's just go ahead and run through them. I see I'm currently at x equals 8. So my zeros are at x equals something, something, and 8. I always like to list them in order. So let's go ahead and work from right to left. I have a minimum at x equals 5.253. 5.253, that is a relative minimum at x equals 5.253, 3 decimal accuracy. Working to the left, I have an x-intercept, looks like 1, and it is indeed 1. 1. Y-intercept should be 40. Yes, it is. F of x equals 40. So y-intercept is 40. Y equals 40. And I have a maximum at negative 0.920. negative 0.920. I've got a final x-intercept that looks like negative 2.5. It is negative 2.5. Let's go ahead and evaluate f of 7. I could do it from the home screen, or if I just type 7, then I'm staring at my calculator and I just hit 7. X equals 7, enter, y equals negative 114. Absolute min, absolute max. Keep in mind, graph goes up forever, graph goes down forever, so there is no absolute extrema. And then where is f of x less than 0? F of x is less than 0 anywhere the graph is below the x-axis. So that would be below the, from negative infinity to negative 2.5, including the endpoints, and then between 1 and 8. Parenthesis over here. Final answer. All right, here's another one. Why don't you try this one? Pause here, play when you're ready. All right, let's go ahead and clear this out. Let's go up to expressions. We can graph multiple expressions at the same time if you want, but no need to. Let's go ahead and just edit this one. I need negative x to the fourth. Negative x to the fourth. So, oops. Try that one more time. Negative x to the fourth. So I want this to be a fourth power, and I want to lead with a negative backspace. The negative and the minus button are the same thing. Negative x to the fourth plus 5x. I am just gonna do this. I'm gonna go right here, back, plus 5x minus 1. Minus 1. All right, let's go ahead and graph it. I can also just go down here to plot graph. There's my graph. Auto is turned on. Here is the whole graph that I expect to see. Now keep in mind, it's x to the fourth. Just like on the previous problem, we had x to the third. X to the third I expect to look like that, and that's what I saw. X to the fourth, my standard x to the fourth would look something like this. This is what x to the fourth is supposed to look like, kind of a W graph. It's negative, so it would actually be upside down, an upside down negative graph. So I have 1, 2, 3, 4 x-intercepts. So I expect to see something like that, yet this is what I see. Now, if I hit minus right now, minus, 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 I'm kind of zooming out to see the whole graph. And what you can kind of start to see is that it actually does look like this, except this part of the graph right here is shifted way down. So you can kind of think it looks like this, but even more so like this. So we've got kind of a failed hump in this graph, this part of the graph right here, which is perfectly fine. There's no issues there. That just means I have only 2 x-intercepts, 1, 2. So when I go to find zeros, there's supposed to be 4 zeros, but only 2 of them are actually going to be real numbers. The other 2 are going to be imaginary, and your graphing calculator is not capable of finding imaginary solutions. We can find real solutions with the graphing calculator. We cannot find imaginary solutions with the graphing calculator. So later on in a couple of lessons, I'll teach you how to find the real solutions with the calculator, and then algebraically we can find the imaginary solutions. But for now, we're just focusing on real solutions. All right, so this is the graph I have. If my cursor, let's go all the way to the left. So the y-intercept is at -1, which of course it is. Y-intercept at y equals -1. X-intercepts, scrolling to the right. Let's see, that's 0.200, 0.200, x equals 0.200. Technically, I could just write 0.2, and that's also the same thing as 0.200. But my suggestion is if you put 0.2, I think you mean exactly 0.2. If you put 0.200, then I think you have more digits. You just stopped after the third, which remember, I want 3 decimal accuracy. Go ahead and put those trailing zeros just to be safe. And then If I keep going to the right, we have a maximum at 1.077. 1.077. And then keep going to the right. I have an x-intercept at 1637. 1.637. Relative min, there isn't one. Absolute minimum, there isn't one. Absolute max is just going to be the same as that relative max, x equals 1.637. F of negative 4, if I go here and I just type negative, let's try that again. Let's try that again. What do I have to press? I'm still kind of rough with these calculators. I'm not 100% on these calculators. So sometimes I still have to guess and check a little bit. Ah, there we go. Oh, I know what it is. So when I'm hitting the minus key, the calculator is not recognizing that I'm hitting negative. It thinks I'm trying to subtract something, so it doesn't quite understand. So when I go to hit negative 4, I hit negative and nothing happens. But if I hit 4, it populates with a 4, and then let's just go back and correct it to negative 4. Enter. So negative 4, negative 277. Keep in mind, if that wasn't working and you couldn't figure it out, go to calculate, go to x equals, type negative 4, oops, don't type it a second time, and then that will spit out the y value of negative 277. Negative 277, negative 277, negative 277. F of x is less than 0 for all of this portion of the graph, so that would be negative infinity to the first x-intercept of 0.200 bracket, union from bracket 1.637 to infinity. Final answer. All right, let's try one last problem. Go ahead and type this in your calculator, figure out all these answers, pause here, play when you're ready. All right, let's go ahead and clear this out. Back to expressions. Now, keep in mind, I'm leaving this as f of x. This is clearly says h of x. It doesn't really matter. If it matters to you, then it matters to you. Feel free to change f of x alpha h. If it makes you happy, go for it. I really don't care. So this is 2x cubed. So I want 2x cubed. So I'm going to back 2x cubed. And then we want minus 40x squared, minus 40x squared. And then I want plus 19x plus 55, plus 19x plus 55. Lock it in. Let's go ahead and graph it. Notice I don't see anything. Why don't I see anything? Because auto is turned off. So let's go turn auto on, hit the back button to get back up here. Auto, there's my whole graph. Notice it was a cubic. Hey, that looks like a cubic. Let's identify everything. Where is my cursor? My cursor is right in the middle there. So let's just go all the way to the left. All right, so I have an x-intercept at negative 0.941. X-intercepts at negative 0.941. I have, go to the right, I got a y-intercept at 55. All right, keep going to the right. I have a maximum at 0.241. Maximum at 0.241. If I keep going to the right, I have an x-intercept at 1.502, 1.502, 1.502. Remember, 503 would have also been acceptable. I am team truncate. I really don't care about rounding, so I don't give it any thought. Keep going to the right. Minimum is coming up at somewhere around 13. 13.091. 13.091. And then we have a final x-intercept over here, somewhere around 19. 19.438. 19.438. 19.438. 8. All right, absolute max and absolute min. It's a cubic function, goes up forever, goes down forever. There is none and none. H of x is positive between the first two x-intercepts and to the right of the third. So between the first two would be negative 0.941 comma 1.502 brackets because we're including the endpoints. Union bracket 19.438 to infinity. And then I need h of 21. So h of 21, if I just type 2, 1, enter, it spits out 1336 for y. 1336. That is the basics of my NumWorks calculator. Throughout the year, we'll learn some more basic operation, but that gets you pretty far along the path to knowing everything you need to know about a NumWorks calculator. Fantastic. Enjoy.